Hi, this is Dr. G. I'm going to walk you through a problem where we're just going to graph a quadratic function using the properties of a quadratic function. Now, I'm showing you this problem because I want you to see the process, and what I want you to do in the homework is do all of these steps in your notebook before you graph the function in Newton. So graphing in Newton is a lot different from graphing on paper. So I want you to do it on paper first so you have an accurate graph and you know how to get the graph before you start dragging points around in the little tool in Newton. Because when you take a test, you're not going to have a computer, you're going to have pencil and paper, and you need to know how to do it. And also, graphing functions is not about just graphing random points and then connecting the dots. That is what we do when we first learn about how to graph or what a graph is. But now in Algebra 2, we want to accurately graph using the properties, the characteristics of the functions that we're graphing. And so we don't plot very many points at all. In fact, we just plot a few points, and they're key points. They're important points. And so I'll walk you through that for a quadratic function. So we're going to graph f of x equals negative 2x squared plus 4x minus 6. So it's a quadratic function. It's in standard form. The standard form is f of x equals ax squared plus bx plus c. So the first thing we want to note is, first of all, we know that a quadratic function is going to be a parabola, and we know what that looks like. It's like a U-shaped graph or upside down U-shaped graph. And first thing we can do is we can look at the number a. That's called the leading coefficient, the coefficient in front of the leading term. And we can tell the orientation of our parabola. In our case, our leading coefficient is negative 2. So a is negative 2. Since that number is less than 0, since it's negative, we know that our parabola is going to be opening downward. So we know in advance what it should look like, so that when we're finished graphing, we can kind of verify that it looks right? If we got something that opens upward, then we know we made a mistake. We can go back and fix it. All right, so the properties we're going to use to sketch this graph are, first of all, we're going to find the axis of symmetry. We're going to find the vertex of the parabola, and then we're going to find two additional points on the parabola. So we're really only finding 3 points, the vertex and 2 additional points, but we're going to figure out those points using the axis of symmetry. The axis of symmetry is a vertical line. It's not part of the parabola, but it's a vertical line that sort of cuts the parabola in half. Its acts as sort of a mirror. So the left half of the parabola is a mirror image of the right half of the parabola, and that vertical line is the mirror. And we can get the equation of that vertical line from the function f of x using the quadratic formula or remembering this formula. So the equation of the vertical line is x equals negative b over 2a. Remember, a vertical line always has equation x equals some number k. A horizontal line is y equals some number k. So we're going to look for the vertical line with equation x equals negative b over 2a. That will be our mirror image. And then we're going to find the vertex of our parabola. The vertex of our parabola is the highest or the lowest point on our parabola. In our case, since our parabola opens downward, our vertex is actually the highest point. Now, the vertex always lies on the axis of symmetry. So it lies on our parabola, and it lies on that vertical line, x equals negative b over 2a. So that means the x-coordinate of our vertex is at negative b over 2a. we know the x-coordinate has to be the same as the x-coordinate of every other point on that axis of symmetry. They all have the same x-coordinate. And how do we get the y-coordinate of the vertex? Well, we have to plug it into the function. So the y-coordinate is f of negative b over 2a. So that's only one point. We need at least two other points to get the whole graph of the parabola. And we don't want to just plug in random numbers and get random points, because we might only get part of the parabola if we do that. So we want to find key points, points that are useful. So one very useful point is the y-intercept. And we know how to get the y-intercept of any graph. We just plug in x equals 0. But then what would the other point be? We need one more point. So if we've already got the y-intercept, then another point we can find is its reflection. And that means its reflection across that vertical line, or the axis of symmetry, right? The mirror image of the y-intercept. Or, so we're done if we got the vertex and then those 2 points. Or instead, we could look for the x-intercepts, if it has any. It might not have any. If the graph does have an x-intercept, it will have 2 x-intercepts, because one will be the mirror image of the other. So those are the points we could look for. So let's get going. The axis of symmetry for our parabola is the equation x equals negative 4 over 2 times negative 2. And if we simplify that equation, we get x equals positive 1. So that is the equation of a vertical line. Okay, it's not just a point, it's a whole line. So now let's find the vertex. Remember, the vertex lies on that axis of symmetry. So it has x-coordinate 1. And to get the y-coordinate, we got to plug 1 into the function. So let's do that. F of 1 is going to be negative 2 times 1 squared plus 4 times 1 minus 6. If I simplify that, f of 1 is negative 4. So the vertex is the point 1 comma negative 4. All right, so I'm going to find the y-intercept. The y-intercept, remember, we plug in x equals 0 to get the y-intercept of any graph. So f of 0 is negative 2 times 0 squared plus 4 times 0 minus 6, which is just negative 6. So then the y-intercept is the point 0, negative 6. Now let's look for the x-intercepts. Let's see if we can find any x-intercepts. So to get an x-intercept, we just set y equal to 0. So now we're solving a quadratic equation. And we just learned the quadratic formula. To solve this quadratic equation, we can use the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug these numbers in. So negative b plus or minus b squared minus 4 times a times c. And it's all over 2 times a. And if I simplify all of this, I get 1 plus or minus square root of 2i. 2 complex numbers. Well, those are solutions to the quadratic equation, but those are not x-intercepts because they're complex. And remember, in the xy plane, those are all real number coordinates, so we can't plot any complex numbers in the xy plane. So this means that we have no x-intercepts. No x-intercepts. So back to the drawing board. We still need one more point on our parabola. So let's go back and find the mirror image of the y-intercept. So I'm going to find the reflection of the point 0, negative 6. So the reflection across the axis of symmetry is going to have the same y-coordinate. So what we can do is we can take our function and set f of x equal to negative 6, and then solve for x. So we're going to find all the points that have the y-coordinate -6. We already have one of them, the y-intercept. Let's see if we find any more. So we set y equal to -6 and solve for x. So adding 6 to both sides of this, I just get 0 equals -2x squared plus 4x. And then if I divide both sides of this equation by -2, just to simplify it, I get 0 equals positive x squared minus 2x. That can be factored. So I get x times x minus 2. Now, the zero product property says that either x is 0 or x minus 2 is 0. The second equation tells us that x would be 2. So there's two x coordinates that go with the y coordinate -6. The first one gives us the point 0, -6, which we already had. We already knew that point. That was the y-intercept. The second one is new. That one is the point 2, -6. And that is the mirror image of the y-intercept. So I'll call that the reflection. So now we've got 3 points. We've got the vertex, we've got the y-intercept, and then we've got the reflection of the y-intercept. And we've got the axis of symmetry, so we can tell if our graph looks right. So let's put it all together and get the graph of this quadratic function. So now we're going to graph f of x equals -2x squared plus 4x minus 6 using those properties. So remember, we got the axis of symmetry, which was the equation x equals 1. The vertex we got was 1, -4. Y-intercept was 0, -6. And its reflection was 2, -6. So first let's sketch the axis of symmetry, the vertical line with the equation x equals 1. Oh, forgot, I have no x-intercepts, right? So x equals 1 is that vertical line. It's a dotted line because it's not part of our parabola. And then our vertex is on that line. It's the point 1, -4. And the y-intercept is on the y-axis. It's 0, -6. Its reflection is 2, -6. And notice where that reflection is. It's on the other side of the axis of symmetry, and it's the same distance away from the axis of symmetry that the y-intercept is. They're both 1 unit away from the axis of symmetry. And now we can connect those dots with a nice smooth curve. So it's opening downward. We can see there's no x-intercepts. And we've only used 3 points. Notice we did not make a table of values. We didn't just start plugging in random numbers for x and getting y coordinates. When you do it that way, you could be picking the wrong points. So you just need 3 points to sketch a parabola. And this is how you should be doing your homework before, and you should be doing all this on paper, get the graph before you start moving things around in the application in Newton. All right, happy studying.